FBF.2 Learning Target 2.3. Okay, so now we are going to be taking a look at creating an explicit formula when we have the recursive formula. Okay, so if you're struggling with creating explicit or recursive by themselves, we have those other learning targets that you can take a look at to make sure you know what you're doing there. So let's now take a look at and determine what it is about the recursive and the explicit that's the same that we can use. Okay, so remember, recursive, we go a sub n equals a sub n minus 1. We have a sub 0 equals. Okay, so the a sub 0 is that 0 term, or that start, and then to the a sub n equals a sub n minus 1, if it's arithmetic, we're adding and subtracting the common difference, and if it's geometric, we're multiplying or dividing the constant ratio. Okay, with the explicit, we like to start it with a sub n as well, which I've talked in other videos about how there's other ways we can write that as well, like with f of n or f of x or y. Okay, all those would work. But with the explicit, we take that 0 term first, and then we are either adding or subtracting the common difference if it's arithmetic, or times them by the constant ratio if it's geometric. And we don't divide, right? Like here we have the division. We just multiply by the reciprocal. And then that's times the variable. And that has the variable raised to an exponent. So going back and forth between the two should be pretty easy. Okay? We kind of ignore all that part. And then we just take this number, this one, and the 0. Plug the 0 in first, then either the common difference or common ratio in second, attach the variable. The recursive side doesn't have a variable, doesn't have an input, because it's all about the outputs for recursive. Remember, that next output is equal to the previous output, then we apply the growth. The 0 term, the starting number, is where we start. Okay, the explicit, we do have to add that variable, but we still use the start and the growth. Okay, so again, it comes down to that start, or that 0 term, I use those interchangeably, and how it's growing. Whether it's arithmetic or geometric, we treat it the same way. So that's all you have to do is identify those pieces and then plug them into the new one. Okay, so looking at question number 1, my start number is negative 14, my growth is plus 3, so that tells me it's arithmetic. So I go a sub n equals my start, negative 14, plus 3, because it's arithmetic. I just put the n right down there at the bottom. And that's all there is to it. Okay, so looking at all these growths, I can see these first ones are all arithmetic. So if we really quick wanted to do a geometric one first, looking at 12, okay, now notice these are all multiply. If they were divide, I'll make up an example of if it were a division one. But 12, okay, there's where we start, there's how it grows. So a sub n equals my start times my growth, because it's geometric, because I'm timesing, the variable becomes an exponent. Okay, so it's actually pretty simple because we use those same two pieces of information. Now let's say we had a geometric that looked like this, divided by, let's say 2, and a sub 0 was 1/2. Okay, so, no, not 1/2. Let's do 2/3. Okay, or we could do just a regular number if that's better, 4. Okay, so actually let's start with a bigger number. Let's say 1024. Because if we're dividing, usually we start with bigger numbers. Okay, so again, it started there, so I'd go a sub n equals 1024. But instead of dividing by 2, I have to multiply by the reciprocal. So if I made 2 a fraction, I'd put a 1 under it. The reciprocal means I just flip it, and I change this to a multiply. So dividing by 2 is the same as multiplying by 1/2. So it doesn't change my problem. It just puts it in a format that works with the explicit. Okay? All right. So take a look at these. Try some on your own first. Make sure you know what you're doing. And then you can kind of finish this video up to check your work. All right, so I'm just going to jump right into it. Okay, number 2, it starts at 8, so I go a sub n equals 8. We're adding 4, so I add 4 times it by n. Number 3, we start at 19, growing by negative 4. So a sub n equals 19 minus 4. 4 is my growth, so I put the n there. Okay, number 4, a sub n equals a sub n minus 1 plus 10. There's my growth. A sub 0 equals 39. So a sub n equals 39 plus 10 times n. Okay. Now, if I really wanted to on 5, I could say I'm going to go y equals instead. My start is negative 13, so I put a negative 13. My growth is minus 8, so I'm going to put an x there. Okay. I could even go like this. On number 6, my start is 28. I could even go y equals, and my growth is 30. Positive, I could go positive 30n, and then positive 28. Okay. I could even change that n to an x. Okay, so you can kind of rearrange and write these however you want. I like keeping the starting point first, just because I think it makes it easier to deal with if it turns out to be a geometric. Okay, I think that's pretty useful to have. Okay, now could I do f of n instead? Yeah. And then my start would be negative 31, and I'm subtracting 100 n amount of times. I could even do f of x. Okay, start negative 7, and I'm adding 200 each time. And I put an x there because it's f of x. Okay, so there's lots of different ways I could do that. Now look at 9 and 10. Now these ones have the first term. Okay, so there's 2 ways I can tackle these problems. I can start it the same. Go a sub n equals, my start is 10, but that's my first term, not my 0 term. So I could go 10, then I would add 8, but realizing that it's my first term, I would actually have to take it back to the 0 term by not just putting n, but putting n minus 1. Okay, so for 10, I would go a sub n equals my start, 35, minus 8 times n minus 1. Okay. Just due to that nature of the pattern for explicit needing the 0 term for it to work out and connect the input to the output. Okay. Now the other way I could do these, if I don't like doing it that way, would be to simply say, well, I'm adding 8 and I have 10. So if I made a table, 1 is 10, 2 would be 18. Going backwards, 0 would be 2. And I could put 2 there, and then I would work it out that way. Okay, so I can, if I want to, change that to the 0 term or do the n minus 1. There's lots of different options there that we have. Okay, all right, now let's do the geometric ones. So start at 3, so a sub n equals 3 timesing by negative 4, and it's geometric, so the n goes up top. Notice up here, no exponents for my variables. Down here is going to be full of them. Okay, number 13, start at 1. A sub n equals 1 times negative 6 to the n. Number 14, start at negative 3, grows by negative 3, so this one's going to look pretty similar. Negative 3 times negative 3 to the n. Okay, number 15, if I wanted to, again, I can go y equals my start times my growth to the n. This one you can't really rearrange the start and the growth for geometric. Okay, for 16, start at negative 3 times the growth to the n power. Okay, 17, if I wanted to, I could go f of x equals my start, 1, times my growth, 4 to the x power. Okay, 18, I can do the same exact thing. Start at 2. Maybe I want to go y equals this time. Start at 2 times by 3 to the x power. Okay, so there's lots of different ways you can write it again, and any way you do it, it's going to end up with the same thing. Now again, take a look at these ones. Now they're starting with the first term instead. Okay, so again, that's going to throw us off. So, one way I can do it is to go a sub n equals my start, or my first term, times my growth. But instead of just times to the n power, it'd be the n minus 1. Because that minus 1 would then undo what we did there with the first term. Would take it back like it were the 0 term. Okay? So we can do it that way. So in 20, it would be a sub n equals 1 times 6 to the n minus 1. So if we see a 1 here instead of a 0, we've got to take it back to the 0 with the minus 1. Now, I don't have to do it that way. I could just as easily decide I'm going to take 1, because if I were to make a table, right, my first term would be 6. Oh my goodness, would be 1. Second term 6, third term 36, and so on. So if I go back to the 0 term, that would be 1 over 6. So I could make my a sub 0, and then it would be 1 over 6 times 6 to the n. Okay. So that's up to you and how you do it, but in case you see those 1s down there, that's kind of what we want to deal with right there. Okay? All right, guys. That's as simple as it is to go from recursive to explicit. Remember, it's all about finding the common difference or common ratio, the growth, finding where we start, or the 0 term, putting it in the format for the explicit. Okay? And if you have explicit go into recursive, just the opposite. All right? There we go, guys.